Go. Okay. So we're going to solve equations today. So for every single question, you're going to be given some expression with log in it. It'll also have an X in it. Okay. And you'll have an equal sign. Obviously, we're looking for, or we're solving an equation. So we have an equal sign. Now, we're going to solve for X. Okay. There's a bunch of different methods we can use depending on what you're given. So that's why I have 7 examples today, because I'm trying to show you a little bit of everything you might come across. So we're going to solve for X, but also for these guys, we're going to verify. Because remember, the base of your log has to be positive. So that's that little guy, which it usually is. We never really run into a case where it's not. We haven't yet. But also your argument. So this big chunk here, that has to be positive. So whatever we find X to be, we have to plug X back in and make sure this whole thing stayed positive. So that's why we're verifying, okay? So here's our first one. We're going to solve for X, then we're going to verify. We have log base 4, 5X plus 1 equals log base 4, X plus 17. So when you want to solve something like this, whenever you have a log expression equaling another log expression, and the bases are the same, what you're allowed to do is just completely drop the log part and just set 5x plus 1 equal to x of 17, or x plus 17. So if 4 to the something is equal to that, and it's also 4 to that same something is equal to that, and they're equal to each other, well, then those two arguments have to also be the same. We're forcing them to be the same. So there's your expression. So when this is the case, you're allowed just to drop the log part. You have your basic 5x plus 1 equals x plus 17. I'm going to subtract x to both sides, so I get 4x on the left. I'm going to subtract 1 to both sides, so I get 16 on the right. I'm going to divide each side by 4, and you get that x equals 4. So we've solved for x, which is always our goal. And then we just have to verify. And this is free marks on your test next week, okay? All you got to do to verify is go log base 4 and plug in your x you found into that expression. So it'll now be 20, 5 times 4, right, plus 1. So that would become 21. And then log base 4 on the other side, x plus 17. So 4 plus 17 is also 21. So we are happy because this guy and this guy are greater than 0, right? Or they're positive. So we're happy. And also we got the left side equaling the right side. So we know our x is right. We balance the equation. So that's all you got to do for verifying. You can do kind of the lazy verifying. Okay. Next type of question. This is totally different. Here we have all base 10s, right? We have log base 10 of 5x, but it's minus the log of a bracket, x minus 1, and all of that is equal to 1. So this is not like the first one. We don't have just something equaling something. It's not that simple. We got to do something else. So when you have 2 logs that are both base 10, and you have a minus in the middle, we learned that yesterday that was actually a quotient at one time, right? So we can go back and rewrite this as just one log expression with a quotient instead, or with a numerator and denominator. So what I mean by that is you have log, your numerator is 5x, and your denominator is the x minus 1. So I've just rewritten that as a fraction. That's what we did yesterday. And then that is equal to 1. So now what you have here is you have a log expression, and I give you the answer. I am telling you 10 to the power of something is this, right? That's what logs are, but I'm telling you what the something is. When I give you the answer on one of the sides, that's what the exponent is, okay? So what I'm saying is 10 to the power of 1 equals that. So I'm going to rewrite it, show you what I mean. So again, this is a base 10 here. That's where I'm pulling out that number. So the base of the log becomes my big fat base, so 10. Whatever the answer is, like this is my answer, that becomes the exponent on the 10. And that has to give me, or has to be equal to, the argument. So that's how you'd rewrite that guy as just a plain old equation with no logs in it anymore. You got rid of the log. So that means you can solve this. So to solve this, to solve for x, I see I have a denominator. I'm going to get rid of my denominator because we don't like fractions when we're solving. But just remember, what you do to one side, you have to also multiply to the other side. So on my left-hand side, I'm going to actually distribute that 10 in. I have a bracket. So 10 times x is 10x. And -1 times 10 is -10. And on my right, I just have 5x. So there you go. Now everyone knows how to solve that. Okay, I'm going to subtract 5x to both sides. So I have 5x on the left. I'm going to swing that -10 over to the right. Divide off the 5, and you get that x equals 2. Okay, so now let's go be lazy and verify that these guys don't end up being negative. So you go to the original. Log of 5 times x, so your x is 2, minus the log of 5 minus 1. Oh, sorry, it's 2, not 5, pardon me. 2 minus 1 equals 1. So I have the log of 10 minus the log of 1 equals 1. So the reason I was doing that was to make sure that when I plug those x's in, the arguments are positive, which they are. So this is all I require of you when it comes to verifying. All I require of you is to plug in your x's, simplify your arguments, make sure they're positives. So you're good. You could stop here. If you so choose, you can keep going with the verification to make sure your answer was really right and make sure you have the left equaling the right. So what I mean by that is here I'm asking you, 10 to the power of what gives me 10? Well, the answer is 1. Then I'm asking you, 10 to the power of what gives me 1? Well, the answer is 0. And then I copy down my right side and I see that I have my left equaling my right. That's a full verification. You can stop there just to make sure you have positives. Okay? On to the next. Okay. Log 6x minus 3 equals 2 minus log 6x plus 6. Okay. Any guesses? Nico? Move stuff around. You are free to do so. So what Nico wants to do is he wants to take this whole negative log 6, send it over to the other side, and it becomes positive. Then you have two positive log or two logs added together. When two logs are added together, that's the product rule. Yes? Okay. So what I have is log 6. Okay, I'm going to do this all in one step, so stay with me. I know I'm doing the product rule. So the product rule says you write it as log 6, and then you just multiply the two arguments together. So imagine I moved him over, he became positive. So I know it's the product rule now. So I multiply those two factors together, but then I still have the 2 on the right. So I just use the move stuff around, use the product rule. Okay, so now in order to solve for x, I need these brackets gone. I need to work this out. So you're going to FOIL that out. Okay, when you FOIL this guy out and simplify it, you should get x squared plus 3x minus 18 equals 2. So I just did first outside, inside, last, and simplified the middle terms. Okay, so now that you've gotten it to this step here, you have a nice simplified log expression to which I give you the answer. Whenever I give you the answer, that is actually the exponent that goes on the base of the log. So I can rewrite this as 6 is my big old base. My answer is now the exponent, and 6 to the power of 2 has to be equal to my argument. So I set that up, my logs are gone, and now you're going to solve this like you would any other quadratic equation. So you learned how to solve quadratics in Foundations 20, and then again in Pre-Calc 20. This is a trinomial, okay? So I'm going to, in my head, I know that's 36. I'm going to subtract 36 to both sides. So I'm going to get 0 equals x squared plus 3x minus 54. Okay? I've just subtracted 36 to both sides. The reason I want it to be equal to 0 so that I can factor it, right? This is an easy trinomial to factor. Open up your two brackets. What two numbers multiply for 54 and also give you a 3? It's a 9 and a 6. Then just get your symbols right. It's going to be a -6 and a +9. Okay, so from this guy, we figured out that x equals -9, and from this guy, we figure out that x equals 6. I just set them equal to 0 and solve. So I have my two answers, or so I think, but we're going to verify. Okay, so in this case here, you're going to see why verifying is important if you didn't believe me. So I'm going to start by verifying the -9. So what I do is I go to the original. I would have log of base 6, and then you open up the bracket and it's x minus 3. So I have -9 minus 3. I'm going to stop. Because right away, I see that if I simplify that argument, it's -12. I don't even care what the other one, I'm not even going to plug in -9 together. It doesn't matter. Already, I know that -9 cannot be an answer because when I plug it in, it gives me a negative argument. So that's what I mean is your verifications can be real lazy. Okay, to show me that, stop. That's not going to be an answer. That's not going to be an answer. Okay. So then let's do my next verification. Let's verify with 6. When I plug 6 in, I have log base 6. When I plug 6 in that first bracket, it's 6 minus 3. So it's just 3. I'm all right with that. And then that equals my right side, which is 2 minus log base 6. And when I plug 3 into that, or sorry, 6 into that bracket, it's 12. So again, lazy verifications, you take a look at what it gave you for your argument. We're happy. Those are both positive. So 6 is an answer. So pardon me, I think I forgot to write the solution set for the previous ones. In this solution set, the answer is only 6. You would not put -9 in the solution set. Not included. Alrighty. Okay, now we're going to get into some different ones. Okay, so for these guys here, you'll see you have no logs. No logs. These were the types of questions we actually saw in chapter 7. The exponential function chapter. And in chapter 7, if I gave you this, what you would have done is you would have tried to rewrite 200 as a base of 5. So you got like 5 to the x equals 5 to the 7 or whatever, and then you'd say x equals 7, call it a day. The problem is you cannot write 200 as a base of 5. That's impossible. So when it's impossible and we can't solve it that way, what you're allowed to do is you're allowed to take the log of each side. So this is what that's going to look like. When it's impossible to break that 200 down, you say, okay, well, I guess I'm taking the log of each side. And when you take the log of each side, it's automatically base 10. Okay, so that's what I got now. I've got the log of both sides. I'm allowed to do that because if I take the log of one side, as long as I do it to the other side, I'm good. Now on your left, you have the power rule. So I am going to send that x down in front like we learned yesterday. And this is what I got. Now, to solve for x, your goal is to always get everything away from x. So just like we would do if there was anything else attached to x, we would divide it off. And once you do it to one side, you do it to the other side, and you have x equaling, it is not the log of 40. Do you hear me? Do you hear me? You do not divide 200 by 5. That's not the way logs work, okay? So if you want to actually solve this, you have to take your calculator, figure out what log of 200 is, write that decimal down. Then you have to figure out what the log of 5 is, write that decimal down, then divide those two decimals. You do not make those a 40. It does not work, okay? Someone will do it. That's why I'm yelling, because I'm hoping by being loud you'll really hear me, because someone's going to do that on the test. I just know it. I feel it in my soul. Someone will do it. Okay, but it's not going to be any of you. It'll be someone in period 2, right? Or Connor. Just kidding.
Hey, Adrian said
Okay.
that.
So on your calculator, when you figure out the log of 200, it should be something like 2.30. When you divide by the log of 5, I got 0. Like it was 6989, whatever. At this point here, you can also all allow it. If your calculator allows it, type in log of 200 divided by log of 5 and do it all in one step, then round your decimal. But regardless, you should get something like 3.3. So if you're not getting 3.3, you need to fiddle with your calculator until you do. And I think the solutions in the textbook are all, I want to say they ask you to round to 2 decimals, okay? So this would actually be 3.29. But I am not going to penalize you if Avery has 3.29 and Kaylin has 3.3. You did it right, obviously. Okay. All right. Now, I'm not going to verify. Why am I not going to verify? I already know what my bases are. My bases are 10. I'm happy there. I already know my arguments are good. Yeah?
No way to verify.
You could plug the x in here, but if your x is 3, 5 to the power, that's obviously positive, right? But your base, like, yeah, you don't have to. So it's when there's like more like a bracket, you have to plug x in and simplify the bracket. Okay. All right. Okay. So same type of deal, same type of question we just did, but what I'm doing here is I'm making the exponent a little bit more complicated. Okay. So again, last chapter, I would have said, oh, see if you can make that a base of 8 or even 2, because you could change that to a 2 and that to a 2. Neither of them work. You cannot make this a base of 8 or a base of 2. So when that's a scenario, you take the log of each side. So I have 2. Oh, I won't jump that far ahead. Sorry. I was going to put the 2 in front. Can I do it now? I know I'm going to do the power law. Okay. So this is going to be log of 8 to that. But I know once I put the log in front, I can use the power rule and swing this exponent down in front. So I'm going to do that step right now. So if I swing that exponent down in front, it becomes a big fat 2x minus 3. And then I'm taking the log of 8. And then I also have the log of the other side. Okay. Now, there are multiple ways to do a question like this. I'm going to show you the complicated way, and then for the next example, I'll show you the easier way, and you just decide what works best for you. It's just the way your brain functions, okay? So the complicated way for this guy is to distribute the log 8 into both of those guys, okay? Because I have 2x minus 3 times that, so it's like I have both of them times log 8. So this becomes 2x log 8, and then it becomes minus 3 log 8. And then my right-hand side, I can't do anything with him. Okay. So now, your goal. Sometimes we kind of lose sight of what our goal is. Don't forget, your goal is to get x all by itself. X is right here. So we have to just start getting stuff away from him. Okay, so I'm going to take this guy and send him over to the right so that I only have 2x log 8 equaling log big number plus 3 log 8. So I've just sent that over. Oh, I forgot the 8 there. Pardon me. There you go. Then again, I want to get x all by itself. You are allowed to divide stuff off. You are allowed to divide off a log 8. But what do I also want to divide off? A 2. I'm going to divide that whole term by 2 to cancel out the 2's and by log 8 to cancel out the log 8. So there's only an x left. But what I do to one side, I have to be fair and do to the entire other side. or you could have written it individually. And either way, you're dividing both of those guys on the right by 2 log 8. Okay. So then I have just x all by itself. Now, this is where your calculator is your best friend. You figure out what's the log of 15,109. Add that to the log of 8, but you got to times the log of 8 by 3. Then you set that, you equal that out, and then you divide that by the log of 8, but you have to times that log of 8 by 2. Okay? I know it sounds like a lot. So one at a time, figure out what the log of 15,000 blah, blah, blah is. Okay? And I got 4.18-ish. Then figure out what the log of 8 is, but then you have to times that by 3. Okay? And when I did that, I got 2.71-ish. Then that's all divided by the log of 8 times 2. I got 1.8. I rounded here. 81. I think it was like 805 or something like that. Okay. Then you're going to add those two top dies together. You're going to divide by the bottom, or if your calculator is unbelievable, you type all of it in one step. Regardless, you should get about 3.81. That's the long way. Okay. And again, I'm not going to verify because I look at my bases. I'm happy, right? They're already positive. Okay, now I'm going to show you another way to do a question similar to that, okay, without distributing. So here, if this was a question from chapter 7, I would have told you to make your life easy and divide off that 5. There was a question like that on your exam, actually, which I'm going to hand back today. So when I divide off those 5s, I have 4x plus 2, and that just equals 40. So I got rid of that 5, no need to have it there. And that's what I'm working with now. Okay, I cannot rewrite 40 as a base of 4 or a base of 2. Okay, so when that's the case, you have to take the log of each side. So I have log 4, x plus 2, and log of 40. Okay, just like I did in the previous question, that x plus 2 is going to swing in front. And then I just have log 4 and log 40. Okay. So in the previous question, the more complicated way, it's fine if you do it that way, is distributing that log in, right? We had log 4x, and then it would have been log 4 times 2. Okay? The other way you can do it, don't distribute, just divide off the log rate now. So what you're allowed to do, if you don't want to distribute, go like that. Divide off the log. And again, on the right, it is not going to become log 10. You don't divide the 40 by 4. So now what we have, if we do that, is we have x plus 2 all alone on the left. And then on the right, find this decimal. Okay, so on your calculator, figure out what's log of 40. And then divide that by the log of 4. And you should get, oh, I did it the other way for this one. You should get something like 2.66. Yeah, okay. And then to solve for x, you subtract 2 to both sides. Boom. Okay, so we did that whole question without distributing it at all. So the previous way works just fine. Distribute or don't. Just divide it off right away. I'm good with either. All right. And again, I'm not verifying. My arguments are already positive. Okay, last one. I wanted to show you what happens when both sides have an x in the exponent, okay? Exact same deal. Follow the process. You cannot get these bases 4 and 3 to ever be the same. So you're stuck with them. So in that case, I'm going to log each side. I'm going to look ahead because I know if I'm logging each of these, that is now going to become the power law, and that exponent is going to come in front. So I have 2x minus 1 in front times the log of 4. I have x plus 2 in front times the log of 3. Good luck, win thousands of dollars. Okay, bye. All right. So in this scenario here, this one's a little bit more complicated. Because if I said to divide off the log 4 like we just did in the previous question, okay, sure, the log 4 is gone here, and you have a log 4 here, but you still have it attached to the x plus 2, right? Like that bracket is still there. So we have distribution on both sides, which makes it a little bit more complicated. So in this scenario, I am going to distribute, and I'll show you what happens, okay? So when I distribute, I get 2x times the log of 4, and then I just have negative log 4. And then I have x times the log of 3, and then that's added to 2 times the log of 3. All right, so I've distributed. I have no more brackets. But just like you learned in grade 9, if you have x's on both sides of the equation, you got to get them over to one side. So that's what I'm going to do here. I'm going to take this x log 3, pull it out, and bring it over here. And then I'm going to take this log 4 and send it over. So I have the x logs on one side and the non-x logs on the other. So this guy is going to come over and he'll become negative. And this guy is going to go over and he'll become positive. Those two guys are just switching spots and their symbols will change when you do that. So I have 2x log 4 minus x log 3. That's the red one I moved over. And then I have 2 log 3 plus log 4 on the right. Okay, this is where it gets a little bit unique. In math 9, if you had a 2x and a minus x, you would just say 2x minus x is x and you'd call it a day. You can't do that. That's attached to a log 4, that's attached to a log 3. It's like apples and oranges. They're not similar terms. Make sense? But the problem is I still can only have one x in my answer. Like I just want x equals. I have 2 x's. What do I do? Any ideas? How can I make those 2 x's 1 x? What last step? Tell me. If you're lost, tell me. Because I want my x's on the same side. Whenever you're solving for x in an equation, don't make that face. You've been doing it for like 5 years. Say you had this, Avery, and I asked you to solve for x. You'd minus 2x to both sides. You know. Okay, so now you know that step. So now back to this one. I cannot combine those x's. I can't. It's apples and oranges. It's a log 4, log 3. How do I just get one x in my equation? No, you can't use the rules here. Well, if you did use the rules here, this would go back as an exponent. This would go back as an exponent. This would go back as an exponent. It wouldn't really get us anywhere. You want to divide by x? So if I divided by x here and divided by x here, I have to be fair and divide. Now you have an x in the denominator. You just made your life way worse. Okay? X is a common factor in those two terms, right? What if I did that and all I have is 2 log 4 left minus log 3 left? I factored out the x because it's the common factor. And when you do that, you just have an x out front. Yes? Yes? Okay. And then your right-hand side didn't change. And now I want to get x all by itself. So to be able to do that, I'm going to divide off by this giant factor I just found. So that crosses off completely. But if I divide the left side by that whole big ugly thing, I gotta divide the right side by that big whole ugly thing. So now this is where your calculator is your best friend. You're gonna take the log of 3, you're gonna times that by 2, then you're gonna add that to what the log of 4 is. You're gonna get a big fat decimal, then you're gonna divide that by log of 4 times that by 2, then subtract log of 3. I'm gonna give you 30 seconds to try to work that out in your calculator. And I wanna hear a yippee come out of you when you get the answer of 2.14. The answer is 2.14. Okay, I'm going to stop the video for now because that's the lesson. Did you get it? Neil, that was the most pathetic yippee in the world. There, okay, you got it?